Hey, how's it going, everybody? This is Kian Andruski, doing a little first episode here of working on an espresso machine. So basically, what I've been thinking is I want to design an espresso machine from scratch. During quarantine, COVID-19, 2020, I've gotten really into coffee and coffee culture. So what we're going to try and do is see if we can build out our own espresso machine. I've done some research, but I'm basically starting from scratch. So during these episodes, we'll basically be messing around, trying to figure out as much as we can about espresso machines, learning how they work, learning a lot, learning a lot, and trying to figure out how to make one from scratch. A little bit of background about me. I have a degree in mechatronic systems engineering from a local university. So I feel like I do have some background to kind of get off the ground and running with this kind of stuff. But I've never built a product like this from scratch. So we'll see how it goes. Okay, how an espresso machine works. We're going to watch this together. Cutaway. There's this one really good video. This one. This is what I want to watch. Okay, it's a quick one, so we'll watch this together.
So this is the schematic of our triple heat dual boiler system
Triple heat dual boiler. Okay, let's see what
that we
he
use
means
in our
by that.
Oracle and our dual boiler espresso machines. So what we've got here is we've got our two boilers. These boilers are the heart of our system. So let's follow the path of the water from the tank to the cup. So we have our water tank, 2.4 litre water tank. Comes in through our 15 bar pump,
So they got two pumps. So they got one pump.
through our
It
overpressure
looks
valve.
like
So
it's pumping. Okay, let's take a look at this. 15 bar pump feeds water through this first boiler into the boiler that then dissipates water through the coffee. And then they've got a second pump, which the water stays in this first tank. I'm guessing that's used for steam. And oh, that's pretty cool. So the steam that's created in this first boiler is used to heat the water that's going into the second boiler, which is then used for dissipating through the coffee. So they gain quite a bit of efficiency here by using the excess heat in this boiler to preheat the temperature of the water before it reaches the main boiler, which they have a heating element, and they get that perfect temperature control before they push it through the coffee. So that's a good design. Seems pretty good.
we limit our pressure of our extraction to 9 bars, flows through the heat exchange
So
in
nine
our
bars is kind of
steam
the,
boiler
for my
into
research, 9 bars is the ideal pressure to keep the water at while it's flowing through your coffee puck for espresso.
our espresso boiler, down through our three-way solenoid, through our heated group head, into our 58 ml portafilter where you've got your prepared coffee. The other path that it takes comes through our 4-bar pump, straight into our steam boiler.
Mm-hmm.
Our steam boiler is controlled to around 135 degrees C or around about
Get that
1.7
steam
bar, so
going.
we
Yep.
get that instant and continuous flow of steam. Now, because we've got two independent boilers, two
Yep.
independent heat systems, we're able to extract espresso and texture milk both at the same time. One of the keys to getting great tasting coffee.
So if you want to make a nice latte or cappuccino, you want to be able to use that steam to froth your milk, heat your milk, give it that nice texture to be combined with your espresso for a perfect latte cappuccino. So pretty cool design. I think that any espresso machine kind of needs this sort of double boiler. Seems like the best way to get those kind of coffee drinks, cappuccino, latte. So let's see what he has to say next here.
So what we've done here is we've taken commercial systems and we've engineered them into a domestic footprint to sit on a bench top at home.
Yeah,
And
it's
another
key.
first for Sage at the London Coffee Festival 2014.
Okay, let's look at this espresso machine for a sec because I want to kind of point out some of the main parts. So starting from the bottom here, we have the drip tray. So this is where if anything kind of misses your cup or if there's any kind of leakage after you take your cup away, you need something that's like easy to clean, right? So the drip tray is essential. It's a sheet metal part, it looks like. Um, and then just has a cavity where it collects liquids. Easy to clean. That's kind of the key design element for our drip tray. Moving up the right here, this piece right here is our steam wand. So I've seen this with a lot of espresso machines where it's got this kind of like flexible nozzle to insert into your little milk container. So one thing that I'll have to do during this kind of design is kind of look at, is this an off the shelf part? Does every espresso machine kind of use the same wand attachment? And I'm going to have that same question next for this piece right here, which is the portafilter. So the portafilter is the piece of your espresso machine that you can twist off, undo, it comes out to the side. You pour your coffee grounds into it, tamp it with the little hammer tamper that you get with every espresso machine, and then insert it back in. And that's what the water is flowing through to create your nice espresso. So I'm like 90% sure that the portafilter is going to be a part that we'll definitely have to go and find the CAD file for of a pre-existing design. There should be sort of like an industry standard design of the portafilter I'm expecting because I'm pretty sure you can get like replacement baskets, and there's a whole bunch of kind of aftermarket equipment that is built around the similar design. So we'll have to go and research that. And then on the main face of our espresso machine, we've got some buttons, a little display, um, some sort of indicator, dial indicator, and a couple more buttons. So one thing that I've researched with a couple other espresso machines is that we definitely need to have an indicator for pressure on our espresso machine. 9 bars, 9 bar of pressure, which is about 130 psi. Let's double check. 130 psi, 9 bar, 2 psi. Yeah, 130 psi. Uh, that's kind of one of the essentials for a good tasting espresso. So we'll need to find a nice indicator to kind of spruce up our design, and then some nice buttons for, I'm guessing, okay, you can see the 1 cup symbol versus 2 cup symbol there, depending if you're making 1 or 2 espressos. I'm not sure what this button or this button would be. And then your display, I guess you can program the temperature and time that it takes for your water to filter through the coffee. So overall, there's not that many parts to an espresso machine. Obviously, inside we have the boilers and piping and pump and water tank. But in terms of an overall system, it's not overly complex. So I think we can attack this design, and I think we can work on this. So, and then just one more note for this
Is
video
the introduction of the revolutionary dual boiler, now available.
before he goes on and finishes. This piece to the side is another critical part of espresso and coffee in general, is a burr grinder. And what a burr grinder does is it grinds your coffee beans into a very uniform sized particle so that you get a perfect kind of extraction, uniform extraction. Because if you have very large coffee particles, you're going to get bitter taste in coffee. If you have very fine particles, it's going to be very weak tasting coffee. So with a burr grinder, the way that it works, it produces a very uniform and adjustable sized coffee particle for you to kind of dial in and make a really nice espresso with. So We're not going to be building that. I don't think we're gonna be building a burr grinder into our espresso design, but I'm probably gonna need to get one. I don't know. I don't have one yet, but it'll be interesting to see what comes up as we start working on this. Okay, I don't know what this piece is to the side. Maybe some sort of valve for letting off the steam pressure if you're not using that, but not really sure. So let's see what he has to say at the end here.
Available in colours. It's available in red
Mm,
and in black.
red and black, classic. Okay, so at the end there, he kind of touched on the aesthetics of an espresso machine, and for my research, the designs are all so similar. You've got stainless steel and black. That's like your main aesthetic. Sometimes you throw in some red ABS plastic to make it look a bit fancier. You know, the ones you see in some coffee shops. But other than that, the designs all look the same. They're kind of these chunky displays at the top. You've got this open area where you put your coffee in, portafilter in, and you've got your drip tray. And look at this. They're all the same. They're all the same. Buttons on the top section, middle section, portafilter, drip tray. There must be a reason why they're all the same. It's probably extremely functional, cheap to build, and safe to design. So one thing that I want to do with my design is change up this aesthetic a little bit. I think that where's that my little sketch of what I wanted to do was we're gonna try and see if we can build something that's a bit asymmetrical. So what I'm thinking is we'll put the dials on one side, the buttons on the top, portafilter kind of offset, and try to add a little flair to the design. Cool. Okay, so this was kind of like the intro to this series. We're gonna design this espresso machine. We're gonna see. We're gonna do a lot of engineering on this. We're gonna see what kind of stuff we can source locally. We're gonna compare to existing designs. We're gonna go through all the calculations to figure out what it takes to make an espresso. So thanks for watching. Let's see where we can go here.